Jeb to talk about Proguard. Enjoy.
Thank you. So I had to sneak on the stage earlier to get a selfie with the group. So let's talk about Proguard. Everybody loves Proguard, right? Show of hands, loves Proguard? You're liars, I've read your Twitter. I'm Jeb Ware, I work for American Express. One thing I'm always thinking about is how to secure my app from attackers, from somebody who might want to reverse engineer my app. So to do that well, I wanted to get another perspective on that. I wanted to give myself the perspective of the attacker. So I started decompiling other people's apps. So the way that works is you ship your app, you compile your code, you package in your resources, all of those things into an APK file. You upload that to the Play Store. I download that to my phone. This is all hopefully review if you've shipped an app before. Once I've got that app on my phone, I can use a couple of ADB commands so I can figure out first where that APK went on my phone. And then I can just pull it onto my laptop from there and then unzip it, right? An APK is just a zip file. So one of the files inside that zip file is classes.dex. That is all of your code that's been compiled into Dalvik bytecode at that point. So I can't read Dalvik bytecode myself, so I'm going to translate that to Java bytecode using an open source tool. There's a lot of different options. I've got one of them on the slide. And then once I've got Java bytecode, there's a whole bunch of options for Java decompilers, so I can turn that into Java source code. And at the end of that, I've got something that looks kind of like this. This resembles your source code. It's not your source code exactly. Your comments are gone. The parameter names are lost, so you see the parameter there is param main activity. It's just the decompiler gave it a name based on the class. There's been optimizations, so constants got inlined, but for the most part, this is the same functionality as your code, right? This is the same as doing the same thing that your source code does. And importantly, the class names, the method names, member variable names, all of those things are the same. So as I'm trying to reverse engineer your app, those become my roadmap, right? I can look at this and see pretty clearly this is doing view binding on your main activity. Now I'm a good person, but there are people out there, I've told, that are not good people. So they're looking for your license verifier, right? So they're gonna disable that, make a cracked version of your app, upload it to some cracked app store. Or somebody's gonna look for your special sauce algorithm that's there, copy that out, rip you off that way. Or one thing I like to do is find your networking stack and figure out how you're talking to your server, and then try to use that to find weaknesses in the way you talk to your server, either the way that the server is accepting your auth token or whatever it is. And all of these things, these are based on somebody being able to understand your code when they've decompiled it. What you would rather that person see when they decompile is something like this. This is what obfuscated code that was run through Proguard looks like when you decompile it. So this class, I don't know what it does. This is actually from an app of mine, but I still don't know what it does because the class name is C. It implements the C.E interface, whatever that one is. But I really can't read this and figure out what it's doing. If I wanted to figure out what this class was doing, I would have to say, okay, well, I'll have to find this AD class and then figure out what that calls, and then hopefully somewhere down in there, there's a system call or there's something I can recognize to try and figure out what it's doing. Or I work backwards and I see what code is calling into this class to try to figure out what it's doing that way. But as it is, it becomes a lot more difficult for me to figure out what your code is doing. So I began decompiling a couple apps. I was looking for bug bounties. These are programs where companies will say, okay, find a vulnerability, a security vulnerability in our app, and we'll pay you a little bit of money to disclose that to us privately. So I started doing this for a couple of apps, just for the learning mostly. And so the first app, I noticed it wasn't obfuscated, right? It looked more like this. And then the next app that I did still wasn't obfuscated. So I began to wonder, how prevalent is code obfuscation among Android apps? I just assumed everyone was doing it because, again, I have read your complaints on Twitter. But I took all the apps off my phone and I made a pretty simple script that just looked at all of the code declarations. So your class names, your function names, and tried to guess which ones were obfuscated, right? Short little names. And then gave each app a score from 0 to 100%, right? 100% being completely obfuscated. You can't actually get to 100%, but you can get close. And then 0% would be not at all. So what I expected here was a bimodal distribution, right? A big chunk of them would be down by 0. They haven't turned Proguard on. And a big chunk would be up by 100 because they did turn Proguard on. But as you can see, that's not what we've got. We've got about half of the apps are down there in the 0 to 20% range, so they probably didn't turn Proguard on. But then the other half of the apps, they're not up at the top, up at 100%. They're spread out really far across the middle. So a quarter of the code, 25% of your code obfuscated up to 75%. And I was really surprised by this. Like, why is there such a range for, you've turned Proguard on, why is so much of your code still not obfuscated? And then I remembered what's happened every time I had a problem with Proguard. So you get a compiler error, or you get a crash at runtime, and you search for it, and you end up on Stack Overflow, or you end up on GitHub issues, and you see something like this, and it's the top voted answer. And you're like, okay, let me put this into my app. And it works, sort of. It makes the problem go away. Your crash goes away. But it does that by saying, Proguard, you can't obfuscate this big chunk of code. So if you do this for, this one does a library, and you do this for one library, and then you run it into another problem, and you do it for another library, and all of a sudden, only 25% of your code is obfuscated, right? That's how you end up down the left end of this graph. So this is the bad answer. It's got 10 thumbs up. It's got some ta-das on there, but it has some thumbs down. If you're wondering how people figured that out, it was because Jake Wharton came along and said, don't do that. So the goal of this talk is to give you a little bit of a better understanding about how Proguard works so that you can write better configuration than that. And I did blur that person's name. If you're in the audience, I apologize. But I'm hoping to give you an understanding about how Proguard works, what it is doing to transform your code. So Proguard is an open source tool. It is for Java code in general. It's actually not Android specific. But it does ship with the Android SDK, and the Android build tools will run it for you if you tell them to. There's just a Minify enabled switch to turn it on. And when you turn it on, you get 3 benefits. It does 3 big transformations to your code. It does code shrinking, which is it finds the unused code in your app, code that's not being called anywhere, and removes it. It does obfuscation, which gives you those meaningless names. So instead of, super secret license verifier, activity factory, whatever, it's just A. And it does Java bytecode optimization, which we're not really going to talk about because it's off by default, and I'll explain why in a little bit. So when you invoke Proguard, the first thing it does is it needs to load in a configuration file. So like any command line app, there's a bunch of switches you can do, dash verbose, dash don't optimize, right? You're turning modes of operation on and off. And then you give it a bunch of keep rules. So you're saying, Proguard, I need you to keep this class. You are using those to define entry points, and I'll get into that in a little more detail. But you have to load in all of these configurations to tell Proguard how to operate on your code. And then you give it your code, right? So your code, at this point, it has been compiled. It's not dealing with Java source code. It's dealing with Java bytecode. So this is your Java bytecode. It could have started as Java source or Kotlin source. At this point, when you get to Proguard, it's all the same. It loads in third-party libraries that you're using. So your networking stack, your image loaders, your animation helpers, whatever they are. Loads those in from jars or AARs. Again, those are just Java bytecode at this point. That's what they ship, those libraries do. So all of this is the code that you ship with your app. This is the program class pool is what Proguard calls it. This is the code that Proguard can transform. It also loads in the library class pool. This is code that you're not going to ship, but you're counting on it to be there, right? So the Android framework. You don't ship, base context, whatever. But you are going to call those codes. So Proguard needs to know about it so that it can validate your code, but it can't transform it. So it has to keep it in kind of a separate pool. So Proguard has loaded in the keep rules, which were mostly patterns, right? You don't list out classes, each class explicitly, but you list out these kind of patterns. And it's got your code, so it finds all the places in your code that match the keep rule patterns, right? You are telling Proguard, you need to keep these things. These are entry points into my code. So if you're making like a Java command line app, that's your public static void main method. If you're making an Android app, it's an activity, right? Because the framework is going to load your activity. It's going to instantiate your activity based on an intent. So these are all of the entry points that Proguard definitely needs to keep in your code. So all of the places in your code that are entry points that match the keep rules, it writes those out as seeds.txt. So as Proguard's running through, there's some options for debugging that you can turn on. And by default, the Android configs start with seeds, which is your entry points. So it's found the entry points, and now we want to find your unused code so we can get rid of it. So to find your unused code, we're going to find the used code, and obviously it's just the reverse. So Proguard understands Java code, so it can just step through your code starting at the entry points that you gave it, and all the code that it sees, it marks it as used. So here we've got that onCreate method is an entry point. It references the name variable. It calls this string_util class. It calls the getHello method. That method references this hello prefix field. And we're done, right? We've started at the entry points. We've stepped through all of the code that we can get to. So everything else is unused code, and we can remove it. I want to point out here that it can do a whole class. In the case of the one on the bottom there, that whole class is unused, so it's all gone. But it can also be a little more focused and just remove the class in the middle there. There's a field, just one field that's not being used. So we'll take that out, but leave the rest of the class in place. And again, it writes out some debugging info for you. So this is usage.txt. This is the unused code that's getting removed. Gets printed out as usage.txt. That name seems backwards to me, because it's not the used code, it is the unused code. It should be unusage.txt, but that's what it is. And again, it's just line by line, and so for that string_util, it wasn't removed, but it gets listed because one of its members was. So it's string_util : and then the field that got removed. So now we've got less code now, because we removed all the unused code. Now we can do obfuscation. So we've got still have this concept of entry points. We can't rename those pieces of code because something is expecting to load them. But everything else we can rename. So Proguard figures out what it's going to rename everything to. It does this, it prints out a mapping file, which is exactly that. It's a mapping from the original name to the obfuscated name. But it prints out everything, including things that didn't get changed. So you get a line for the class, and then in an indent, you get all the members of that class. So it's figured out the mapping. It can go through and rename all the code declarations. You see them there. String_util became A. And now it can update the references, right? So to keep the code consistent, it's going to update the references there. And so now we have valid Java code again. This all compiles. The entry points are still there. We can still call into it. Everything's going to work. But you can see, especially that whole class at the bottom, it's been obfuscated, right? It's hard to read what the intent of that was. So once your code's been obfuscated, I'm going to take a little digression here from the steps that Proguard was running through to talk about crash reports. So if you've got obfuscated code and it crashes, well, if you get any code and it crashes, you get a stack trace that gives you, this function was calling this function, was calling this function. But if your code is obfuscated, those are the obfuscated names, and that's hard to read. What you would rather have is something like this, with your full class names and function names. So what you have to do, Proguard did obfuscation and gave you that mapping file, and you're just going to use the same mapping file to reverse the process, right? You go from obfuscated stack trace to a de-obfuscated stack trace. You can do this by hand. You can look up, each class and method in the stack trace and work backwards through it. That's really tedious, so you don't need to. But this is, since the mapping file enables you to do this, this is why you don't publish your mapping file. It's not, it's not like a private key to a signing key store or something, but you still don't want it getting out. But so you don't have to do that by hand. You can use retrace, which ships with Proguard. So it's in the Android SDK under Tools Proguard bin. You just give it the mapping file, and you give it the stack trace as a text file, and it'll print out the deobfuscated stack trace. Or you can use this sweet GUI, which is sort of a JavaX swing GUI from a long time ago. But it's very functional, and it works, and it has that sweet animation at the top that loads. I screenshotted it mid-animation. I didn't get the whole animation for you. Sorry about that. But there's a tab on the left there for retrace down at the bottom. When you give it, again, you give it the mapping file, you give it the obfuscated stack trace, it'll deobfuscate for you. And again, this is in your Android SDK installation under Tools Proguard bin. But fortunately, much of the time, you shouldn't have to do this because your crash reporting tool, if you're using Crashlytics or something like that, they're going to keep the mapping file for you. They're going to automatically do that deobfuscation so that when you see a stack trace, you see a crash report from them, it's already deobfuscated. Okay, back to what Proguard was doing. So it's done obfuscating your code. It's done transforming your code at this point. So now it does a dump, which is a huge text file representation of your code. This is one interface with one method that takes no parameters, and it's that big. I have a sort of a toy app that I use for testing Proguard things. The code for that is like 600K. The dump file is 18 megabytes, so this is enormous. I suppose it could be useful. I've never actually needed it. But then last thing Proguard does is it needs your code, right? So it writes out your transformed code to a jar. A jar, again, is just a zip of class files. So, all right, let's look at that whole sequence together so you can see the steps and how they flow. It loads in your config files. It loads in your code. It matches your code, or it finds your code that matches the keep rules. That's your seeds, the entry points into your code. It removes the unused code, writes that out as usage. Does the obfuscation, writes out the mapping file that it used, does that dump file, and then writes out Java bytecode at the end. So it took in Java bytecode, wrote out Java bytecode that has been transformed. Again, the seeds and usage, those are mostly useful when you're debugging, like you're trying to make a rule for something and it doesn't seem to, your wildcards don't match or something. So those are useful to debug that. At build time, mapping is useful, again, for deobfuscating a stack trace. Dump is probably not that useful. But so keep mapping for any build that you release into the wild, because you may need to deobfuscate a stack trace. If you get that from somebody who comes to your desk and shows you a crash rather than from your crash reporter. But the important thing to see here is the keep rules that come in at the beginning, well, the whole configuration, because if you get those wrong, the whole process goes wrong. So you put bad input into the front, and it's just going to screw up step by step by step. So let's talk about keep rules. Again, these define the entry points into your code, where something else, either by reflection or just by calling the class loader, needs to call into your code. And it's not your internal references, right? You don't need a keep rule for all of the code that you're using. Proguard understands Java code references. It's just the entry points that Proguard can't see. So the top one, these are a couple examples. The top one protects the getters and setters on a class that extends Android View. So you'll see it kind of looks like Java syntax, but with these kind of wildcards. So you don't have to list out every class, right? You can do it by patterns. I'm not going to go through the whole possibilities of the syntax here. The Proguard manual has, in my opinion, pretty good descriptions of all of that. And I'll have a link at the end that has all these links. But I do want to go through the difference between the keep rule possibilities. So there's 6 different possibilities, and they all work a little bit differently for the shrinking phase versus the obfuscation phase, and for classes versus class members. So, if Proguard is going through and has to make a decision at each of these points. Can you remove this class if it's unused, right? Can you rename this class member? And each of these keep rules affects those a little bit differently. And class members, just so I'm clear, is static fields, member variables, and functions inside of a class. So if you don't have, or for any code that doesn't get covered by a keep rule, Proguard just does its thing, right? It removes what's unused and it renames everything else. If you say -keep, so this is what the Android support annotation keep does to your code. Any class that has that on it cannot shrink the classes or the class members, even if they're unused, got to keep them, and you cannot obfuscate any of it. Keep classes with members is kind of a variation on that. It only applies if the class has the members that are named in the class specification. So the previous one, right, this applied to all class members, whereas this one applies only if you have a class member annotated with the keep annotation. But again, once you have that, you can't shrink or rename any of it. There's keep class members, which keeps the class members, right? So an example of why you would use this is for parcelables. So the parceler needs to find this creator field, and it's going to do that by reflection at runtime, so it needs to be there even if nothing references this field, right? So can't shrink it, can't rename that one. There's keep names, which keeps the names the same. And then keep classes with member names is the same distinction as that keep classes with members was a variant of keep. So it only applies if the class has the members listed in the class spec. But again, so it keeps the name. So it just says don't obfuscate this code, but you can still shrink it if it's unused. Then the last one is keep class member names. So this just says for the class members that I've got listed, you can't change the names. You can still remove them if they're not used. You can still remove the class. You can rename the class, but you just can't rename these members. You might use this one for JSON serialization. So JSON is matching up the members of your, the JSON payload with your class by name. So it needs to have those names the same. But the class can get renamed because it doesn't need to match based on that. It can be hard to know when you need to write keep rules or which ones you need to write. So Proguard 6, adds a new option called add configuration debugging, which adds some instrumentation to your code so that when some code executes that probably should have had a keep rule but didn't, you get something like this in your logcat. So it says, oh, this would be if I hadn't protected this class with that I was calling from JSON. Proguard says, hey, you did some reflection here and it didn't work the way you expected because you probably should have added this. So if you turn this on, you can get this sort of info to try to help you out as a starting point. Eric LaFortune of GuardSquare, who makes Proguard, he has a blog post coming soon that's going to have a little more detail and sort of a walkthrough about how to use this option. Again, this is in Proguard version 6, which is new. If you want to get that, you need to switch to Android Gradle plugin version 3.2, which is in alphas as of right now. And you only want to turn this on in your debug builds, right? Because this basically includes the mapping information so that it can give you those useful debug statements in the logcat. All right, so you got all these keep rules. You put them into a text file. If you set up a new project in Android Studio, it gives you this Proguard rules.pro. It can be named whatever you want. It's just a text file. But then you reference it in your build.gradle with the Proguard files function. You say, all right, my build config needs this Proguard file. The default, again, if you make a new project, file new project, you get the get default Proguard file, which ships with the Android SDK. And it just has some sort of generally applicable rules that most Android apps would want. Most of the examples that I showed in the prior slides came from this file, actually. And there's actually two versions of this. There's this one has optimizations off. There's also Proguard-Android-Optimize, which turns optimizations on if you want to use those. Third-party libraries that you're using might include Proguard files in their AAR. So the library would actually use this in their build.gradle, right, to package it into the AAR. This is saying any app that's using this library needs to have these Proguard rules. and then it gets picked up automatically. When you include that dependency, you don't have to worry about adding it. They're going to get added automatically. Most libraries don't do this, in my experience. So you're more likely to need to check out a library's README file. They might reference rules that you should probably be adding. And then you can get some Proguard rules from AAPT. So let's zoom out a little bit. I realize it's a lot. It's okay. Your stats Proguard there in the middle, we shrunk all those steps down into one step, right? The blue ovals are the tools running on your code. The squares are artifacts moving through. Config, we said that's coming from libraries. It's coming from your rules. And it's coming from AAPT. What AAPT is doing is it's processing your resources. It's sort of like semi-compiling them. They're, XML resources aren't loaded as XML at runtime. XML is really inefficient. But while AAPT is in the neighborhood, visiting all of your resource files, it makes some Proguard rules that relate to them. So any activities that you've got in your merged manifest, well, we know the manifest is saying that these might get referenced at runtime, so let's go ahead and make a rule to make sure we keep those. If you've got also not just activities, but services, broadcast receivers, your application subclass. And then if you've got a layout file, and your layout file references a custom view that you've made, well, the layout inflator is going to try and reference that by reflection, so we need to make sure that's there. On-click methods, again, in your layout files, it'll make a rule to keep those. So if you want to see all of the config rules from all of these places that are getting added in, with AAPT, if you want to see that on its own, that's in your build intermediates folder. It's up at the top there. But then if you want to see all of these rules from all sources, you can add another rule that says print configuration, and that just prints out all the rules to a text file. Another option is you can run your Gradle task with -- debug, and when it gets to the Proguard step, it'll list out the path for every config file that's loading in. Proguard's getting Java bytecode from your code through the compiler and from libraries you've included. It runs through, turns Java bytecode into Java bytecode that's been transformed. And then Java bytecode is not what we use to run Android apps. We use Dalvik bytecode because we don't have the Java virtual machine. We have we had the Dalvik virtual machine. Now we have the Android runtime. So that's got to get transformed again. The Dexer transforms that for you from Java bytecode to Dalvik bytecode. And this is why Java bytecode optimizations are off by default because it's optimizing for the wrong target, essentially, right? And DX does its own optimizations, right? It does Dalvik bytecode optimizations. So you're not actually walking through these steps, right? The Android Gradle plugin is invoking all of these things for you, and it's actually doing a heck of a lot more. This is a very small version of the build diagram. But these are the tools that are getting invoked for you under the hood as of now. Last fall, the Android developer blog announced that there are some tool replacements coming out. So DX is getting replaced by D8. Yep. So D8 became available in Android Gradle plugin version 3.0. You could opt into it. It got turned on by default in 3.1 or 3.2. And then, so Proguard is getting replaced by R8. You can opt into this now if you want to try it out as of the Android Studio 3.2 or Android Gradle plugin 3.2 alphas. You can opt into it. You see I kind of combined the two steps because R8 doesn't have to write out Java bytecode. It's not a general purpose Java tool anymore. It's for Android apps. And so it just basically hands your transformed code straight to D8, which can write out DEX files for you. And somebody asked me about the names. I believe what happened is the author of the V8 JavaScript engine came over to the Android team, and he was like, I like the number 8. And so that's how they got those names. So we just spent 29 and a half minutes talking about Proguard, and then I told you it's going away. The good news is everything that we just covered is basically all still the same. It's reading in Proguard config files. R8 actually reads the same format, the same keep rules, all the same switches. Does the same thing with the program class pool and library class pool, and then writes out, the difference is it writes out straight to Dalvik bytecode instead of Java bytecode. That's really the only difference. But you still need to think about, what are the entry points into my code? What is going to get shrunk? What is going to get obfuscated? It's just a new tool doing the same steps. So R8 is open source. You can see commits like every day as they're going in. The issue tracker is open. They've got a Google Groups forum that seems to be basically just a feed of commits and issues that come in. I mentioned you can turn that on now as of Android Gradle plugin 3.2. In the root of your project, there's a Gradle.properties file, and you just say android.enable R8 equals true. This is when D8 came out, it was android.enable D8 equals true to opt into that. If you do that right now, I'm going to warn you, it is not entirely done yet. So like every website in the 1990s, it was under construction. There are a few differences in what seem to be a few bugs as of right now. That's why it's in alphas, and that's why it's opt-in. The mapping.txt is a little bit different. It still writes one out, but it only writes out the things that it renamed. It doesn't write out the things, main activity, arrow main activity. It wants to write out seeds and usage. The code is there. It's not wired up for some reason. So I filed a bug on those last week. They are working on that, as well as print configuration. They accepted that bug. I believe they're going to add that or something like it to R8. So you'll have all these same debugging aids to work on it. The dump file is not there, but who cares? And I will say the Crashlytics plugin right now breaks if you turn on R8. It's just expecting your mapping file from a different Gradle task, and so I'm sure they'll fix that shortly. But beware of that if you try to opt into it and try it out now. Like I said, same keep rule format. They do, some of the documentation uses different names. So instead of shrinking, it refers to tree shaking, which is new to me. I've never heard that. Instead of obfuscation, it's got minification. So it's taking your long code and minifying it. So main activity down to A. You'll see that term a lot more in like the JavaScript world. JavaScript minifiers is a thing. So that's it. So please go, for your sake, just try to obfuscate your code. These are your takeaways at different levels. So if this is new to you, just try to obfuscate your code. See what happens. As you're trying to learn how to do it well, read the default Proguard rules that ship with the Android Gradle plugin, and then read the rules that get generated for you by AAPT. See what you can learn about how to write good rules from those. When you go to write your own rules, try to keep them very narrow, very targeted, right? Your entry points isn't this entire networking library that I've got. It's some function that's being called by reflection. If you've got that working, if Proguard works in your app now, then try out R8, because it's probably coming. Presumably, it will be on by default at some point in the future. So try it out now and file bugs while you can. And then there's a short link there at the bottom, where.to, where like my last name. Where.to/Proguard has links to all the other links that I had in there. It's got links to my blog post where most of these diagrams came from. And that's it. Please go use Proguard on your apps. Are there questions?
So, I activated Proguard, and my app crashes. I mean, that was your example from 5 minutes into your talk, and the wrong answer is just turn off Proguard everywhere.
Right.
So, what are some best practices for those of us who've been through this one to turn it off less, or just be able to start to diagnose those situations? Because otherwise it feels very black boxy.
Right. So, when you get into one of those cases and, you've got an error message that you're looking at, it's usually, reflection failed on this one class that it was expecting to find, or this one class member wasn't there. So you probably don't need a rule for just that, but you need to figure out, oh, it's trying to deserialize my things. It needs to have the members there. I need to write all of my, all the POJOs are in this package, so I need to keep the members of classes in that package. So you need to figure out why did some reflection call fail, and then write a rule to try to target just that thing. And so the diagram where I had, so the 4 quadrants, right? You got to figure out, does it need to have the classes or the class members or both? And does it, can it still rename them and they just need to be there, or vice versa? So yeah, that's the point in level 2 there, is just try to keep your keep rules as narrow as possible to the problem that you're encountering.
That makes sense. If I could just follow up very quickly.
Yeah.
The main problem that you described right there was just reflection, right?
Yeah.
Reflection can cause problems if you are allowing obfuscation, right? Are there any other scenarios besides reflection calls that would cause problems?
Yes, so I mean, if you're trying to load something from the class loader, I'm not sure if that's technically reflection, but most of the trouble you're going to run into is reflection.
Cool.
Oh yes, and J&I, sorry. That was in one of the, thank you. That was in one of the examples was, and I think I didn't call that out, but yeah, you can say, just like in Java, you can say, this is native something, right? That's going to be backed by some native code in the Java native interface, which I haven't actually done, so I'm not an expert on J&I, but I know it's a thing. And so yeah, you would want rules to keep the Java native interface code points.
Thank you.
Yeah.
You mentioned that these crash reporting tools basically revert the obfuscation for you. Mm-hmm. Can you explain how they get a hold of the mappings file, and like you said?
So I can speak for Crashlytics because I've used that. At runtime, or at build time, after Proguard does the obfuscation, the Crashlytics Gradle plugin has inserted a task that will upload that to Crashlytics, upload that to your servers. And they have a unique build ID that they're already using to line everything up. So they just map, or they line up that, find the right mapping file for the build that crashed, and they can do the deobfuscation from there. And that's actually I mentioned the Crashlytics Gradle plugin fails for R8 now because their task that they tried to insert was trying to go after the Proguard task instead of whatever new task R8 is using. Go back there.
So I had a question about the obfuscation. When you were looking at some of the apps that were or weren't obfuscated, did you happen to notice, or I guess I'm not sure how that works, when apps are using third-party libraries, do the third-party libraries tend to obfuscate to the same code, roughly? I mean, obviously some of it's going to be taken out if those methods aren't used, but like, for example, does retrofit or, trying to think of another common third-party library, but like, do those always obfuscate to roughly the same thing? Do you know?
No, not at all, because when Proguard does that mapping, it just starts assigning from A. So I might include retrofit in my app, and you might include it in your app, but when you take all of our code and line it up alphabetically, it's going to be at a different point in the alphabet.
Okay.
So it's going to get assigned a different name.
Okay, so that, yeah.
And
okay.
even between builds, right? So you build once, and then you change something in your code, and you build again. Those things aren't going to get the same. That mapping file is not going to be the same.
Okay.
If you've
cool.
added or removed, classes.
Okay, thanks.
Yeah.
I had 2 questions.
Yeah.
So I wonder about code shrinkage and obfuscation when you unmap everything. So when you go through the unmapping stage with something like Crash Linux, are you getting the line numbers from the code shrinkage, or are you getting your original source code line numbers?
Yeah, it's a really good question. So Proguard retains, well, there's actually an option, right? I think it's -keep line numbers or something. It's in the Proguard manual, and the name has line numbers in it, whatever the option is, to keep the line numbers in the the debugging symbols in the class file so that when it gets deobfuscated, it will be your original line numbers.
Okay, cool. And I wondered if you had any tools or noticed in using Proguard in different apps how much it increased your build time, because I'm assuming it probably does increase your builds of your APK.
It does increase build time a little bit. That varies wildly with the size of your app, right? It's just the amount of code that it needs to deal with. For the trivial app that I test things on, it's just a couple of seconds. But for the main app that I work on, it's probably closer to a minute. But you probably don't want Proguard on in your debug builds to begin with, because you don't want to be deobfuscating every crash you make. I don't know. I make crashes occasionally. You guys probably don't, but I don't want to be doing that every time I do. But yeah, so I don't turn that on in my regular debug builds. So it's not something it's not a pain I feel in my build times. It's just the CI builds, the builds that are going to my QA team, and obviously the builds that are getting published. That's where we have it turned on.
Okay, cool. Thanks.
Thank you.
Hey, thank you for the excellent talk. I'm curious, I believe it's GuardSquare also produces DexGuard. And I remember having a conversation where someone talked about the fact that many sophisticated attackers, Proguard was not really sufficient in order to protect against them. Can you talk about what additional value DexGuard provides over Proguard?
So I haven't used DexGuard personally. I'm roughly familiar with what it does. And yes, it's going to make, it uses entirely different techniques to obfuscate your code. And so, you might decide that is a better fit for your code. It's more secure. Even with Proguard, right, this isn't, now nobody can reverse engineer your code, right? This is just one layer in the many layers that you are hopefully adding to your security moat. Somebody had a diagram earlier with a moat. But yeah, so it makes it harder for somebody to try to understand your code. Not foolproof. And there are, so GuardSquare this is sort of, Proguard is their open source tool, DexGuard is their paid tool. And there are other options for sort of obfuscation packers. So I can't give you like a difference between, but yeah.
So now we know that Proguard increases the build time, and we can use instant run along with it. Can you name some points where instant run messes up with Proguard so that it causes an error or build failure?
So with instant run, is that you?
Yeah.
So instant run does not use Proguard. There is a different shrinker that instant run invokes. And I'm not very familiar with it. I'm sorry, I don't know. I'm not going to have much detail for you there, but I think by default, you don't want Proguard on in your debug builds anyway, where you're running again and again. For the most part, you might turn it on if you're trying to debug a problem. But yeah, I think if instant run is on, there is a different shrinker that is used that I don't know much about.
So there is no point where we can run both together?
Not that I know of. I don't believe so.
Okay, thank you.
Yeah.
Hey, I just wanted to kind of answer the one question about the difference between Proguard and DexGuard, because I had looked into it myself a little bit. DexGuard will actually obfuscate the Dex files, and I think that it actually obfuscates like some of the resources as well. So that will be like Proguard only does the code, right? Like the Java code, DexGuard will go in and do the Dex files, and I think some of the resources that are included in the APK. So you get a little bit more than what Proguard does by itself.
Yes, thank you.
Is it possible to debug obfuscated code, so setting a breakpoint? I always tried it and never succeeds.
Yeah. No. It seems to always screw up, right? Well, so it works for the code that didn't get obfuscated, right? So anything where like the names are the same, the debugger seems to attach. And I haven't dug into this very far, but I think I've had the same experience as you, where it doesn't seem to work right because it's looking for symbols that aren't there to attach to the debugger.
Yeah, that's why. Is it possible, actually?
I don't know.
Any questions up top? All right, chat out and you can repeat the question.
All right,
when we get
can
into
do.
the recording.
So a lot of those keep rules that show up on Stack Overflow, most of them can be, I guess, mitigated by using the don't warn and don't note rules. Can you explain maybe what those are?
Sure. So the question was, a lot of the answers that you see on Stack Overflow, which are a broad -keep rule, you could also, well, so to answer your question, you can solve the same build time errors that you're getting from Proguard using a don't note or a don't warn option. So that says, you say don't note and you give it a package name or a class name, or don't warn, depending on whether you're getting a warning or a note. Right, so that's you telling Proguard. Proguard's telling you, hey, it's giving you a warning for a reason, right? It's saying, I think something is wrong in this code, or it looks like something is referenced here that's not being kept, whatever it is. And so don't warn is you telling Proguard, shut your mouth, I know what I'm doing. So only do that basically if you understand the problem and you know it's not a problem, right? So if there's a code path that's not going to get hit by your code, but they're doing some weird thing in there, so you can turn warnings off that way, but only do that when you understand why there's a warning in the first place. But yeah, so in a lot of cases, you do get warnings that you could just ignore, rather than creating a keep rule to keep a bunch of code you don't need to. Does that answer your question? Okay. And I'm around, all day tomorrow. If it doesn't answer your question, you can try to track me down and corner me.
So to follow up with that, the don't warn, is there a way to figure out, or any tips on figuring out why this warning is happening in the first place? Because my thing is that if I see that warning, I'm just like, all right, but don't warn. Does anything not work? Cool. Or is that the best way?
Well, right. So you can use, the message itself should hopefully give you some information about why there's a warning, right? Yeah. They're not always perfectly straightforward. So, you might need to for me, it's actually reading the Proguard manual to see what that sort of class of warning means to begin with. Okay. And then, if you want to turn on don't warn, just try to make sure you're hitting whatever relevant code paths to make sure you haven't broken them.
Yep. And would those text files that were sped out, not the mappings, but the other two, were those reading those help out and figuring that out, or?
In some cases,
Probably.
yeah. So so Proguard might say you're keeping this class or this function, but you're not keeping the parameter that's getting passed into it, right? So that doesn't make sense, right? If something's an entry point, then all of that should be kept. Sorry, I completely lost my train of thought there. But yeah, so it's about understanding the class of warning message that you're getting.
Gotcha. Okay.
Yeah.
Great talk. Would you recommend the keep annotation or the keep roles in the Proguard?
Yeah, good question. I was having this discussion with somebody on my team literally last week. And it's really a question about how you want to organize things. So I like the keep rules in a config file because it's all of your Proguard things in one place. And then the person that I was talking with had the other side of the argument, which was, well, no, this is my code. This is something about my code, so I want to keep it with my code rather than in this other place. So that's really, I don't have a good recommendation for you there. It's about how you want to organize your code.
Do you have any sense of why they're switching to this R8, or is it just part of a larger effort to optimize the tool chain or speed, or does it make it smaller? Or?
Yeah, I think it's optimizing the toolchain.
Okay.
So it skips the step of writing out 2 Java bytecode in the middle,
okay.
Which helps a little bit. And then I'm inferring and guessing from the public announcements, so I'm not announcing Google's future plans because I know nothing about them. But it seems that they want to be a little bit smarter about the way that they're dealing with resources. So when AAPT sees a custom view and a layout and makes a rule for it. Well, if that layout never gets used, then that rule was worthless and you're keeping some stuff that was never used. So if it was able to analyze the code and the resources all together, it could be a little bit smarter about that sort of thing. And so I think that's their idea by making an Android-specific tool. It can do more Android-specific things. But again, those are guesses on my part.
Cool. Another round of applause for Jeb. That was awesome.